today's lesson is finding and estimating square roots. Our objectives are to find square roots and to estimate and use square roots. A square root is a number b such that a squared equals b. So if I do 5 squared equals 25. That would be a square root. Square root of 25 is 5. We have what's called a radical. That is the sign on the square root. This sign right here, some people call it a square root sign. This is called a radical. Let me find a different color. So that's a radical. A principal square root is the positive number inside of the square root. So 25 in the square root, 25 is called a positive radical. A negative square root is when there's a negative in front of the radical. That would be negative square root of 25. So the negative can never be inside a square root because a number times itself will never get you a negative answer. So even if I say negative 5 times negative 5, it will never equal negative 25. It equals a positive 25. So you can never have a negative inside of a square root. The squares of integers are perfect squares. So we are going to discuss some perfect squares right now that you need to have memorized. So I have 1 squared. The answer to it is a 1. These are perfect squares. So square root of 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 is 64. 9 is 81, 10 is 100, 11 is 121, 12 is 144, 13 is 169, 14 is 196, 15 is 225, 16, 17, 18 you can use other places. And then 25 is 625. So dot, dot, dot is 625. And that is 25 squared. So these are called perfect squares. So if I say what's the square root of 1, you would say 1. The square root of 4 would be 2. The square root of 9 would be 3. Square root of 16 is 4. Because all it's asking is what times itself will get you that number, and that's how we find square roots. So simplify each equation. All right, so 64. What number times itself gets you 64? Well, 8 times 8 is 64, so it would be 8. All right, look in front of B. They have a negative sign. I made it a little bigger for you. So you know it's going to have a negative. And then what number times itself will get you 100? Well, 10 times 10 is 100. Oh, sorry, so it's negative 10. Okay, so this is a little different. You have a fraction, but you also have what's called this plus minus sign on the outside. So you're going to also put a plus minus. And then what you're going to do is you're going to square root the top and square root the bottom. So square of 9, square root of 9 would be 3, because 3 times 3 is 9. And a number times itself will get you 16, and that would be 4. So here's your answer. Also on D, you have a plus and minus, so you have a plus and minus. And what number times itself would get you 0? Well, 0 times 0 is 0. 0 is a neutral number, so it's not really a plus minus, but that's what they have in front of it, so you go along with it. Okay, irrational and rational. Rational means it's a perfect square root, and this one is non-perfect. A non-perfect square root the number will go on forever and it's not repeating. Perfect. I need to write that all in one section. Here. Non-perfect. So, if we look at A, let's see if we can square root it. So the square root of 4 is 2, and the square root of 9 is 3, so it is a rational number, because it can be square rooted. Okay, negative here. Still negative. What times itself? We're going to pretend like there's no decimal, and that would be 12. And then I move the decimal only once. Here it's twice, but when you do write out the answer, you only have to move it once. So you do half the amount of decimals that they have. Okay, square root of 5. Is there a number that goes into square root of 5 evenly? Well, let's try it. 1 times 1, no. 2 times 2, no. 3 times 3, no. And there's nothing in between. So that is, oh, I forgot on B, it's rational, because it's a perfect number. C, it's repeating, not repeating, it's just a decimal. So that would be irrational, because it's not perfect. Square root of 81. I have a plus and a minus, and 9 times 9 equals 81, so that would be 9. And it's a full number, it's a whole number, so it went evenly into 81, so that's rational. Okay, E. So square root of 2. Is that a perfect square root? No, it is not, so it's irrational. And that's how you do this section. Example 3. All right. Between what two consecutive integers is each square root? So again, you have to remember your perfect square roots. So again, you have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and 121. Well, let's go to 11, 12, 144. So, we look at square root of 24. Now, if you look at the bottom here, you see what numbers 24 is between. It's between 16 and 25. So you're going to go, it's between square root of 16 and square root of 25. And then you unsquare them. So square root of 16 is 4, and the square root of 25 is 5. So if you did all your work, it would be between, square root of 24 would be between 4 and 5. Okay, B, you have 12.5. So you have to find it. It's between 12.5 is between 9 and 16, so you would go the square root of 9 and the square root of 16. And then you would unsquare them, so square root of 9 would be 3 and the square root of 16 would be 4. So it'd be between 3 and 4 and 4 and 5. They always have to be consecutive, so they have to be next to each other. It can't be 5 and 7. It will have to be between two numbers that are next to each other. C, I have negative. There's that hidden negative right there that was hiding. It wasn't very big, so you might have not seen it. That's negative 105, so you find a number that 105 is between, and that's between 100 and 121. So, and put the negatives with it. You put negatives square root of 100 and negative 121. Ah, did that wrong. 121. Square root of 100 is negative 10, and the square root of negative 121 is negative 11. So it's going to be between those two. Now, for example 4, it says to use a calculator to find and round to the nearest hundredth. So you're going to go on your calculator and you turn it on. And for you who have the Texas Instrument 30X, you're going to push the second button. That's the one with the different color. Different colored little button. And then you're going to push the square button. So it says X squared. You're going to push that. And a square root sign should come up. And then a parenthesis. And when you do that, you're going to put in 24, and then the parenthesis, and you push equal. And it's about 4.898, but they want you to round to the nearest hundredth. That would be there. So 8 is above 5, so it's going to be 4.90. Okay, is 4.90 between 4 and 5? From example 3, this will show that if it's true or not. Yes, it is. 4.9 is between 4 and 5. So let's try it again. You push second, and then the square button, and then you put 12.5 in parentheses, and you'll get 3.5355. Round to the nearest hundredth. That would be that where the second 3 is located, and 5 is telling me I'm going to go up 1, so it's going to be 3.54. And then you check with B. 3.54 is between 3 and 4. Yes, you did it correctly. Okay, then you have a negative, and you put square, push the second and then the square button, and then you push 105, parenthesis, and it should be 10.246, round to the nearest hundredth. 6 is above 5 and above, so it's going to be negative 10.25. And there's your answer for that. All right, so the formula D equals x squared plus 2x squared gives the length of D for each wire on a tower. Find the length of the wire if the x equals 12. So what we're going to do is, it's saying x equals 12, so that means we're going to plug in 12 for the x's.